For question 5, we're going to need to use the product rule again because there's two parts multiplied by each other and they both have x's in them. So let's let the first part be u, and we can differentiate that, and let the second part be e to the power of 5x minus 2, and we can differentiate that by bringing down the 5 and then rewriting the rest. Very useful step, writing your ingredients. Now we can find dy dx by applying the product rule. We need v times u dash, so that's one lot of this, so we can just write that down. And then we need to add u times v dash. Now here I've got 5 lots of an index expression, and I've also got to put an x in there. So I find it handy just to put the 5, and then I'd probably put the x, it's the next most simple part, and then put the rest. Now here we've got e to the power of 5x minus 2 in both parts of our answers. So it's very easy to factorise it and bring that out the front, and we're left with 1 plus 5x in the brackets, and that's the factorised version. For question 6, we've got two parts, one divided by the other, and they've both got x's in them, so we're going to need to use the quotient rule. So again, write down your ingredients. Let u be the first part on the top, write it down, and then differentiate it. And let v be the denominator, and then it's easy to differentiate that. Now we need to apply the formula, and make sure you get these parts the correct way around. We need to do vu dash first. So v times u dash. So I've got the 5, and I've got this other complicated part, and I've got my x squared. I'd probably write it with the 5, and then the x squared, and then the other index part. And then we need to subtract u times v dash, so that's this times 2x. And it needs to all be over v squared. That's another possible area to make a mistake. Make sure you get the correct thing on the bottom. So squaring x squared gives me x to the power of 4. Now that looks pretty good just like that. You could actually factorise the top because you've got x e to the 5x in both parts. So at this point I'd probably put x e to the 5x out the front of some brackets, and then I've got 5x minus 2 all over x to the power of 4. Now, you might have looked at this and said, how do I know when I need to factorise and when I don't? Because when we did these product rule questions, I seemed to factorise at the end and said it's sort of okay, 6 of one, half a dozen of the other, whether you factorise it or not. But when we've got a situation like this, factorising is really important because it's going to help me simplify out the whole expression. And the answer I get next is going to be much better than this original one, because I can see that I can cancel an x here with one of these x's, and then write my answer out nice and simply, e to the power of 5x minus 2 all over x cubed. And if you'd stopped here, you'd lose a mark compared to a person who went all the way down to here. Now looking at question 7, we've got two different parts here divided by each other. So it's really tempting to just rush straight in and use the quotient rule. The problem with doing that, it will work out, so we could go that way. It's going to take a long time, and the reason it's going to take a long time is because when we find out what u is and we go to differentiate it, it's going to be a part with two terms in it, and every time we use it in our formula, we're going to need to put brackets around it, and we'll get a really long, complicated expression that's going to take a long time to simplify. So before you start, remember your other tricks. If you can, play around with y and simplify it before you differentiate and find dy dx. So here I'm going to start by just rewriting y, but splitting it up into two separate fractions. I've got e to the 2x over e to the x minus e to the minus x over e to the x. Now I can simplify further here and say, well, I've got the bases are the same, so I just need to subtract the indices. So 2x minus x is just x. And over here, I've got minus x, which is minus 2x. Now I've got two simple terms, and I don't need any of these rules. I can just differentiate each term one at a time. So now, I'll continue up here. dy dx, now I'm differentiating. Well, this part differentiates to become itself, so that was very easy. And this part over here, Well, I'm going to need to differentiate what's up here in the index, which gives me a -2, and bring that down the front. Now, when I have -2, that's going to give me +2. So I can think that through in my head and actually jump straight to it. Then I'll need to just rewrite everything that I was given. And again, we're using that rule that when we differentiate something that has a power or a function of x up here, if we differentiate that, then you need to throw f dash x out the front and then rewrite what you were given. And that's what I've done here. Throw the -2 out the front to give me +2, and then rewrite what I was given. And that's actually a really simple question once you've turned it into this form, whereas if you'd started with that quotient rule, you'd be in a whole world of hurt here. And although I didn't list it as a question, just looking at one more example here, thinking about what to do, let's break this one up into individual terms before we differentiate it. Because a lot of people will see there's a fraction here and they'll want to use the quotient rule. The reason we don't need to is there's actually 2 parts with x in them on the top. That's quite a big problem. On the bottom there's no x's, this is just a constant. So there's no need for the quotient rule here. Instead, let's break it up. We've got e to the power of x on 2 minus e to the power of minus x on 2. Now you can think of it as on 2, or you could write it as a half out the front, thinking of that as just a constant number that's out the front. Either way is completely fine. Then when you go to differentiate it, well, differentiating this, you just get itself. So we left with the constant still there, and that's exactly the same. And this part, we bring -1 down the front, so instead of -1/2, we'll have +1/2. And then we rewrite what we were given, and it's quite straightforward, finished.